Hi, this paper is about late reverberation in broadband parametric spatial room impulse response methods. These methods are used to analyze and reproduce room acoustics, and in broadband methods like the variants of the spatial decomposition method, it's quite easy to detect and render early reflections. But what about possible directional characteristics of the late reverberation? To assess whether this can be preserved at all, we have first used a simple model of an anisotropic diffuse field based on many uncorrelated Gaussian noise sources, which are scaled depending on the angle. Such a field may be approximated by a room with sufficient scattering and one absorbing wall or an open window from which no sound should originate at all. We have tested two commonly used estimators, first of all the pseudo-intensity vector, of which we have used a normalized version that for a single source should return a unit vector pointing into the direction of the source. When we plug in the anisotropic diffuse field, we can examine the statistics of the resulting estimator, which turns out to follow a multivariate Cauchy distribution. For one dominant noise source and less dominant other sources, you can see this distribution here. This is the resulting angle of the estimated vector. For the two mentioned hypothetical cases of an absorbing wall and an open window, you can see the angular distribution here. It is much less likely to obtain directional estimates from the direction of the wall, a little bit less likely to obtain them from the direction of the window. In case of time difference of arrival estimation, we have used microphone array simulations to show similar results in the paper. We've also conducted a measurement in our variable acoustics room, where most walls were set to a reflective setting except for one corner. And in the resulting rendering, you can see that there's less energy from the left and from the back, no matter which estimator was used. Also, we were interested in whether such differences can in principle be audible. For this, we have used spectral and directional noise shaping based on the obtained directional estimates. And we have conducted a small listening test where we could see that, using both estimators, the renderings were closer to a binaural reference in terms of spatial impression than a condition where everything after 80 milliseconds was replaced by uniformly drawn directions. This seems to pull to the left, while this does not. Okay, so in conclusion, we can say that both pseudo-intensity vector and time difference of arrival estimation are capable of preserving some late directional characteristics, but only particular distributions can be captured well. In case of the intensity vector, the directional estimates can be derived using a multivariate Cauchy distribution.